Hello, hello. Right. Just a few quick checks as normal. I think we've got things up and running. Seems okay. Audio seems okay. Got music. Right, so plan today is we're going to continue with Unity, and we're going to follow along with Practical Programming's Endless Runner tutorial. It's a 7-part series that they've done, and we're going to be doing our own spin on this, but using this to form the basis of some of the bits that we still aren't fully aware of how things work in Unity. Oh. Cool. So just a little bit more setup, and then I think we'll be all ready to go. Let's bring that volume up a little bit, and Spotify down just a little. I think that'll be a good level in the background. Cool, and then have a green separate somewhere just to check on the health of the stream. And hopefully we don't get any more technical issues with stream and OBS today, but who knows? Never tell. Restream. Okay, this should tell me the health of both streams, hopefully, and give me the chat to keep track of. And let's just test that both streams are working. Okay, I can see that on Twitch. And let's just do a quick check on YouTube. And while we're doing that, we should test that we've got stream elements here. Cool. Twitch looks like it's fine. Let's do a quick test on YouTube 2. Takes a little bit longer to come through on YouTube. Is that because of the latency on it? See if there's a low latency option. Now, where is low latency in YouTube? I feel like there's a setting somewhere. Playlist, no. No. Automatic chapters. Can't see that just yet, but it's not too important. Okay, we'll leave that for the moment. I think this is good enough setup. Right, so back to Unity. Good view of the screen. Top part of the inspector isn't normally that important, so this bit behind the tutorial window shouldn't be an issue. And we should get audio come through from the screen as well. So press play. Yep. Alright, just going to listen in very quickly for get that audio levels fine. So this is the overview of what we're going to do over these tutorial videos. Yep, that seems alright. Hopefully it's not too much of an issue that I'm watching this on double speed. We'll be going slower over the bits where we need to follow along a bit more closely. That's a good start. What I do need to do though, let's bring this across. Okay, that's set. And then if we go down to here to part 1.
Hi guys, and welcome to the first part of the series.
So I've skipped through a little bit before, just to have a quick overview. So I've not actually done these yet.
The player, which will move forward automatically and can be controlled left and right, and the camera, which will follow the player. For the sake of this tutorial, I will assume that you already have Unity installed. So if you don't, install it first, then come back here once that's done. I'll leave a link to another video on setting the
Okay, we have a new 3D
Let's get started.
scene set up.
The Unity hub open, which is where you can see all of your projects, your current Unity version, and general things like that. I'm going to click on the new button in the top right, which will bring up a window asking us to specify a project name and a location to store the project. I'm going to name this MS Runny Tutorial and specify a location to store it. Once that's done, I'll click create. You'll have to wait for a minute or two for it to load. With the project open, let's just get familiar with the main windows that we'll be using in the data. In the middle, we have the scene view. This is simply where we can see all the items in our scene and where they are positioned. The inspector on the right shows us the properties of anything we have selected. On the left, the hierarchy shows us a list of all the items in our scene. Down the bottom, in the project, it shows us all of the assets that we have available to use. If any of that doesn't make sense to you now, don't worry about it, as you'll understand what they all do after using them for a while. The first thing we're going to do is right-click in the hierarchy and create a new 3D object, plane. I'll right-click on it, select rename, and I'll call it the ground. In Unity, the x-axis is left and right, the y-axis is up and down, and the z-axis is forward and backwards. Therefore, to make this longer, I'll set scale on the z to 10, and its position to 40. Next, I'll click on the camera, set its position on the z to -5, so it's right behind the plane, and its rotation on the x to 30, so it's looking slightly downwards.
Okay, wait, slow. I need to slow down already, just so I can follow along. So let's go back to normal speed and just jump back a little bit.
Is forward and backwards. Therefore, to make this round longer, I'll set scale on the z to 10, and its position to 40.
40, okay.
Next, I'll click on the camera, set its position on the z to -5, so it's right behind the plane, and its rotation on the x to 30, so it's looking slightly downwards. Finally, let's create a new capsule. So right-click in the hierarchy, go to 3D Object, and Capsule. I'm going to press F2 to rename it, and call it the player. I'm going to set its scale on the X and Z, both to 0.9, just to make it a little bit skinnier. Then its position on the Y to 1, so it sits right on top of the plane. If I drag it up and press play, you'll see that it doesn't fall to the ground.
Yeah, because we need to add in the rigid body.
Physics to an object in Unity, we have to add a component called the rigid body. To do this, make sure the player is selected. Then in the inspector, scroll to the bottom and click Add Component. Search for rigid body and select that. Now if I hit play, you should see the player fall to the plane.
Okay, so if we move... Oh,
However,
that.
if I change the rotation of the player slightly, you'll see
If we move
that it
this guy
falls
up
over.
and rotate it,
When the player moves, we don't want it to fall over, so I'm
and
going
press
to
play.
enter play here. Scroll down to the rigid body and expand the constraints. I'll check the freeze rotation boxes for every axis. This stops the player from rotating, meaning that it can't fall over.
Okay, reset, reset.
I'll set its position.
And what we want to do is the constraints. We want to freeze the... it was X and Z, wasn't it? Why have we got two sets of constraints? jump back a second.
I'll check the freeze rotation boxes for every axis. This stops the player from rotating.
Why have we got two lots of it though? Oh, rotation position, sorry. I misread that. Okay. Let's move our camera a little bit back, because I think that's a little bit too close. Did he move the camera up? It feels like that's too close to the ground, doesn't it?
And it doesn't make sense to you now. Next, I'll click on the camera, set its position on the Z to -5 so it's right behind the plane, and its rotation on the X to 30 so it's looking slightly downwards. Finally, let's create a new capsule. So right click.
Yeah, I think we want to go up a little bit from this current camera position. So we'll put the Y position up to 5, let's say. That looks better. So the view that we get now should be as the... Yeah, that looks more like a runner. Okay, so we'll zoom out, have a little look from this side. And let's continue on.
Hierarchy. Go to 3 object, 0.9.
Okay, we got our sphere, we locked it in.
You'll see that it falls over.
Yep.
Box on both X and Z, put it at the origin of the world. To make it a bit more visual, I'll right click in the project, create a new folder, and call it materials.
Okay. Running
Inside here,
a materials
I'll
folder.
right-click, create a new material, and call this player underscore map, short for material. I'll drag and drop this onto the player. Then select the albedo, which is just the color, at the top. You can set this to whatever you want. I'm just going to go with a light blue for now.
Does that work?
Now we're going to create our first script. Go back to the assets folder,
And
right
materials.
create a new folder.
Right. Right. Here. And what was our hex value? Where have we got that hex value stored? I think we've got it in Twitch somewhere, haven't we? I'll start remembering this value soon. Bitmarks, Twitch. And I think our color will be in a customization menu somewhere, won't it? Settings, channel, brand, that's the one. Might as well use this. Keep some consistency through the channel. Right, we have our player.
Called scripts.
Okay, now we
Go
got
to
the
double
scripts
click to open it up.
folder.
Here, I'll right click, create
Oh,
a
wait.
new C# script. I'm going to
We
call
want a
this
folder.
player movement. Give it a moment to compile.
Right, new folder scripts. And then in the scripts folder, we're putting a new C# called player movement. And then we're going to open it up, I assume.
Once that's done, double click to open it up in Visual Studios. Once it's open, we can delete these two using tags at the top, as well as the start function, as we won't be needing either of those. Don't
Okay.
worry about what everything else means for now, let's just get right into writing the code. At the top, we'll create some space, then say float, speed, and end with a semicolon.
Okay.
This is how we declare a variable. Float tells it what data to hold, in this case a decimal number,
No.
and speed is the name that we're giving the variable. We want to initialize this variable with a value, and to do that, we just have to say equals, and then our value. For this, I'm going to put 5 as the default. This
Okay.
tells it to start with a value of 5. Finally, to edit it in the inspector, we will add the keyword public to the front. This just tells it that we want to be able to access this variable from anywhere, which you'll see in a moment. If we now go back to the editor, drag and drop this script onto our player, select the player and scroll down, you'll see the player movement script.
Okay, we can speed this bit up because we have done this in other tutorials.
We can modify this variable right here in the inspector. If I go back to the script and remove the public keyword, go back to editor and no compile, you'll see that there is no more option for us to edit the speed variable. I'll go back to the script and undo that, and then below this I'll add another variable, which will be public rigid body, and I'll call this RB. Again, it's just the cursor variable, type of rigid body, which is the physics component of the body, and calling it RB for short. These are all the variables we need to get the plane moving. So now let's go down, create a new method by typing void fixed update. Remove this auto completes. It may or may not be. If it doesn't, just copy down what I have on my screen. Inside here, we'll say vector 3, forward move.
I think we'd rather call this player, but
Forward, multiplied by...
okay, so public void fixed update. Public void fixed update. D. No. And in this, we are going to do, just make a bit more space there. Vector 3. Oh no, vector 3. Forward move equals transform dot forward times speed.
Speed multiplied by time dot fixed delta time. And under it we'll say RB dot move position, open parentheses, and inside them type RB dot position plus forward move, and end it with a semicolon. Vector 3 forward move, the first variable type of vector 3, and we set that equal to
Dot
forward
move position.
multiplied by the speed, then multiplied by time dot fixed delta time.
RB dot
runs at a fixed interval, known as
position
time, and defaulting to 50 times per second for every
plus
second rotation.
forward move.
This is to give the physics engine a stable base to work from, as opposed to a frame rate dependent function like update. Multiplying by time dot fixed delta time ensures that we'll be moving 5 units every second, rather than every time the function runs. Again, if that doesn't make any sense, you'll understand it after using it for a while. Just know that it's something we have to do. RB.move position literally tells the rigid body to move its position, then we specify what position we want it to move to. This is equal to the amount that we want to move forward, added to our current position. If we save it and go back to the editor, we should now be able to test it. All we have to do is scroll down, and you'll see a rigid body slot anchor. Drag and drop the rigid body component into that slot, and then we can save and hit play. You can see how
Okay,
it starts to move forward.
save this.
If we go to the scene view. Great. Now let's add some horizontal control to the player. So now I'm going to be using the legacy input, but if enough people want to, I'll make a tutorial on switching over to the new input system later on. Let me know in the comments below if that's something you'd like to see.
Right, so our player.
But if you're feeling adventurous and want to try to figure out how to integrate it, go check out my other video on making a player controller with the new input system after.
That's alright, we're going to be using the new input controller system that we did the tutorials for yesterday. So that's going to be going to go for. So we're going to move the player into the rigid body slot, and then if we press play, we should see our player character move forward, hopefully. Up he goes. Cool. And we can stop and go back.
Do this. It should provide you with a reasonable starting point. Now back in the script, we'll declare another variable. This will be float horizontal input. You'll notice that this isn't.
Why is it buffering? I've got loads of the video loaded.
Set it within the script. In the update function, we'll say horizontal input is equal to input dot get access.
Okay.
Open parentheses and in quotes type horizontal. I'm going to end this line with a
What's that?
semicolon. To explain what this does, I'll go back to the editor, go to edit, project settings, and then select the input on the side. If I open up the axes, you'll see a list of predefined inputs that Unity has given us. Horizontal is one of these, and if I expand it, you'll see that it's assigned to the left and right arrow keys, as well as the A and B keys. The left and A keys are both negative, meaning
Okay, what we're going to do here is instead of using those, what we want to add in are we want to view package manager, I think. No, can't do that yet. Window package manager, that's what we wanted. And then we want to have a look at, I think it's in the Unity registry, but I'm just going to check here quickly. Yeah, I think we want this. We're going to look for input. Oh, input. So this is the new system. We want to install it in this project. Resource busy or locked? What's running? Let's try again. See console for more details. Why is that not letting me install it? Let's save this and close it. Is it busy doing something in the background? Doesn't look like it. Window, package manager. This, install. Give it another try. There we go. I think it's because we had the script file still open. Okay, then we want to switch over to the new systems. So Unity will have to juggle those over a little bit. We will save this. And then it should reopen. Okay. Right. So now we should have this in our options. Input actions, yep. So this is, yeah, just player controls. And let that load. Let's have a quick look on Task Manager though, while I'm doing this. Yeah, it's a couple of things they're using up a lot. But okay, we'll leave that for the moment. That seems okay. Right, so in our new player controls, now there was a way to do the default, wasn't there? We only did this yesterday. Edit asset, that was it? No? That wasn't it? Now, path control scheme. No, we don't want to do individual ones. There was somewhere where there was a default setting for all of this. Right, let's go to... so we can find our... previous one. What was it? It was CodeMonkey, wasn't it? CodeMonkey input system. This is the one. And then it was somewhere up here. Touch controls, button remapping, input debugger, change action map. Multiple input types. Here we go. So we don't want to use the listen. It was somewhere here, I'm pretty sure. We don't want the stick dead zone. Pass through. Default create input action. Let's have a look at that one. Why is this going so slow there? Right, so on the object we go to player input component. Let's close that. Let's have that open. Right, so on here we got our player. We add the player input component. Player input manager. Player input. Player input. And then create actions, that was it. There we go. Here are our default controls. Let's get rid of the other one. Okay, so we have controls set to the player. And we want to invoke C# events. And then in our player movement script, we're going to want to bring in have a quick look. Right, so we need using Unity Engine dot input system. Why is it not like that? It's because that's up here instead of... I think we wanted this on, which will give us our Endless Runner script here. So we've got all the bindings. Go down to here. So we've got various actions here. Yeah, see, now it's okay. And here we're going to want our private player input. Oh. As player input. Private. Oh. Player input actions as player input actions. And then on awake, good. Right, if I just put awake, apparently that's known. There we go, okay. We want our player rigid body equals get component. Display rigid body. This is going to be our player rigid body. Oh, it's a function. Of course it's a function, so we've got to invoke it. There we go, okay. And then player input actions, new. Player input actions. It's not liking that just yet. But hopefully we'll be able to figure that out. Actions.enable. Clear that one up. Why is this? Player input actions is not found. What are we missing? Player input actions is player input. Oops. That looks okay. Do this as private, that can be public, that's fine. Right, let's save that for the moment. Go back to here. And we'll have a look at our player object. So in our script, we've got the player, that, and that. It's fine. Default map is player. Yeah, that's okay. So, missing directory or assembly reference. Okay, we don't need to do this bit. Input system phases. Right, let's have another look at this tutorial a little bit more. So that's if we use the Unity events version. So if we swap over to here, we can see our events here, and on our player, we can make these different functions, but we don't want to use this. I think we want to use this one. So we've got our player input. Okay. So player input equals get component, and this is of type player input, and we call that function. Let's hold this for a second, and this one. Okay, let's just double check that again. So on action triggered, okay, so we want player input dot on action triggered equals plus equals to subscribe player input underscore on action triggered. And it doesn't like that because we don't have that function yet. But if we make a new private void player input on action triggered, which is a function that takes in the input action dot callback context, and we'll call that callback context just context. And we're just going to log the context for the moment. And we save that. So now when we run, we should see in the console our inputs. So there's our W arrow keys, there's our arrow keys, so they're all the move ones. Space isn't doing anything yet. Okay, let's continue with that then. So if we look at our controls again, our move, we have a move, we don't have a jump. We have a look, and we have a fire, which we'll leave those in for the moment. But what we want to do is we want to add in new action, and we'll call this jump. And the bindings we're going to do as keyboard will be space, which we have to listen in for. And that's part of the keyboard and mouse control scheme. And let's just get our controller. do the gamepad inputs. Connect it up. We might have to restart Unity to notice that that is connected. Yeah. But what we can do is we can just do button south here. And then also, so this is going to be gamepad. What control schemes have we got here? What's the joystick? Okay. Touch, we don't have a jump. So we add binding for touch. What options do we have? Different touch? No, don't want that. Nope. So I think we want touchscreen. Primary touch tap. What's move? We don't have move. Oh, that's because we want to put a button on screen. Let's not bind on touch for the moment. We'll just look at keyboard and gamepad for the for now. So with that, we save the asset, we close it. That will regenerate this C# class. We'll give that a second. And now when we run, it should recognize space as our input. Yep, so there's our jump. And there's our Xbox controller jump. And Xbox move, Xbox look. Keyboard look. And keyboard move. Okay. Nice. We have inputs. So then we have to create our various functions around controlling the movement. So let's do a private void. Nope, not that one. And this is going to be our left-right movement. So what's going to be... Let's just turn the music volume down a little bit there. So for this one, we're going to want a move function, right? And we're going to want a jump function as well. Let's do that while we're here. Let's take those out for the moment. We'll come back to those when we need them. Let's call this initial speed. Oh. And then we want a private float here, which is our actual speed. And we're not setting that up yet. On awake, we want our speed to equal initial speed. So in the Unity controls, we can set a initial starting speed, but we're going to control the actual speed of the player through the script. Okay, for the moment, let's save that.
And there you go, now I can see the various contexts. So I can see the action is in the action map player, it's the jump action, it was triggered by the keyboard space. Then for the phase, this one is the start and it happened on the time of 5.9 seconds. And once again, key, keyboard space, with a value of 1 and no interaction, so you've got the start phase, the perform phase, and the cancel phase. So in order to use this method, then you do some identification over here on the action field, and depending on what action is fired, then you do different things. But if we're going with this method of using this built-in player input class, then I think it makes more sense to use input events for this. So again, you can use both, but here I'm going to switch back, so just like this, and then you do some identification.
Wait, did he not tie it in?
What action is fired, then you do different things.
To actually do the jump? No, okay. Right. Let's have a look at this in a second. Okay, yeah, we've already done that. Got our input actions here. Right, okay. Yeah, I think this is why this wasn't working. Let's go down through all of this. Okay, this is just the this is just the JSON format, isn't it? Yeah, that's a bit easier to see. Okay, so our endless tutorial, endless runner here. This is the build that we want to be using. Let's go to the top of this just to see what we've got. Finding read-only array. Where is this player input actions coming from? UI actions? No. Fill scheme.
Object. And then on this one, we need to access the player action map, and then we're going to access the jump. Don't need to worry about how this script works, but if you want to, feel free to inspect it. So back in our testing input system, here in order to use that, we just need to create an instance of our generated C# class. So it's called player input action, so new player input actions.
But it doesn't look like it's being called player input actions for us here. So let's have a look. Player input actions. And that's capital P. So it can't find that. Now, if I move these two into the scripts folder, move, can it now find it? What was his function called? Player input actions.cs, and we've got our endless runner tutorial.cs. So if we instead copy that and call it that. Oh.
So just construct this object.
We save that.
Then on this one, we need to access the player action map, and then we're going to access the jump action.
Okay, let's have a look and call this endless runner tutorial player input actions. Equals new. Oh. Okay, so it's not that. So what is it called on here? We've got different. So let's go back to see how we generated it.
But like I said previously, you also have the ability to generate a C# class and have a lot more control over it. So let's go to the project window, and over here select the actual input actions asset. Then you got a button to edit the asset, which opens up this window, and then you've got a toggle for the generate C# class. So you can take this one and
Okay, so it's based on we go back to here, checking the project. I think it's actually the player script, right? Which is this one. Input action assets. Ah. Scripts, this. What have we generated a C# class for? Oh, is it uncoupled? Let's close that. Let's rename this player input actions. And then let's generate our C# class. Apply. That's gone. That's now player input actions, and then if we call this that instead, there we go. Right, it's happy now. Nice. No worries. Yeah, we're running through a tutorial to do an endless runner in Unity. But the tutorial on YouTube uses an old input system for Unity. So what we're trying to do is we're trying to use what we did in yesterday's Unity stream, which was how to learn how to use the new input system and try and figure out and remember all the stuff to control our player character here on this endless runner scene. Oh, did I not save it? Yeah, let's save. So for the moment, it should just move forward on its own at a speed of 5, which I'm assuming is 5 meters per second, maybe. And each time we put an input in through either our keyboard or our controller, then we should see it coming up in the console. So we'll let that load. And then we'll, where is this? We're just finding meta file. I don't know where the meta file are held. but we'll ignore that for the moment. So we want the console up, we want to press run, and the player character should move forward, and if we put inputs in, no, we're not getting the logs. So, what have we done differently here? Ah, because this is missing. We want this script in here, I think. Which I think is this one. Yep. Default scheme is NE, that's fine. The default map is player, that's correct. Maybe camera? Let's see what happens with that. So we swap over to the console while it's running. Yeah, there we go. Right, so we've got our mouse being picked up. WASD. Space for jump. Then on the controller, we've got the left stick movement, the right stick looking, and the A button jump. Oh, and we've got fire as well. Fire's hooked up or something. I don't know if we'll have a fire option for this game, but it's good to know that that's in there. Okay, and now what we need to do is we need to subscribe to jump events and stuff like that. So that'll be the next bit.
And then you see all the inputs. If you want, you can modify what file they're being generated in, what last name, what entity, and so on. But here, just leave them as default, and they're required. As you do, you can see over here that generated a C# file, so we're generating a action. Now, if you want, you can open and inspect this. It just generates all kinds of functions and events based on the input action. So, for example, we find a player action map, and over here we can see the player action map right here. And then for the player, we find some actions, so we find the jump action. So over here we can see an interface that implements the jump action, over here the player action. So all this goes on the actual generated. So we've got our jump action and various events start from all the
So this is all the bit that's auto-generated. We don't need to worry about this just yet. Right, we did that. Right, okay. That's what we need. So I don't think we need this, because this is just subscribing to every single input. We're definitely going to have to get better at organising our code here as well. So, player input actions dot player dot jump dot performed plus equals jump. That's our function that we've got below. Now, oh, we don't need to call it. It's just jump. No? No overload jump. Oh, because our jump doesn't have the input action here. Input action dot callback context. There we go. Now it's happy. Right. And then I think we just want our player rigid body dot add force, and we're going to do a vector 3 dot up times by 1 for the moment, just a small jump, and then force mode impulse, give ourselves a jump. So maybe, hopefully, our player should jump when we press the jump button. It might be too small. Doesn't look like it's doing it though. Let's make this a larger jump for the moment. And give that a go. See if that picks it up. Just see if it's a scale issue rather than a config issue. No. Okay. Oh yes, we need to enable it. Okay. Which is up here. So where we have set this, we need to do player input action dot player dot enabled. Right, and then we save that. Hopefully. And then run. Let's see if that is tied together as we want it to. Yeah, there we go. There's our jump. And that works on console. And we can jump in the air. And that works on keyboard. Cool. Right. I think we now have our input tied up. So let's call this one strafe. Right, how do you spell strafe? Strafe. That strafe? That looks wrong now that I misspelled it the first time. I think that's right. Let's double check. Strafe. Nope. Yeah. That's what I want. Yeah, okay, it's right. Okay, and then we are going to go back to here in our player input controls. I think we want an action called strafe. And we're going to bind on our keyboard and mouse. No, we don't want to do this. We want to do new positive negative binding. That's it. And it's a 1D axis. Yes. Okay. So on our keyboard, this is going to be our left or left. Both of these. Can I add both? Oh, you have to do secondary. Primary 2D axis. Right. This is kind of what we want. Composite type 2D vector. The composite type. Can I add a second binding in here? And that should just be keyboard and mouse. This one is in for D, positive, keyboard and mouse, correct. Okay, then we're going to duplicate this. This one is going to be our secondary keyboard input, so left and right. And then we're also going to do no, not there. Delete that. I want to duplicate this. We want to say we're going to use our gamepad Does it not let me use a gamepad? Oh no, because I'm on here instead. Right, our gamepad. Listen. So left stick, left. Yep. This is going to be left stick, right. And we're going to duplicate again. And add in left D-pad left, gamepad, and D-pad right, gamepad. Okay, so strafe is left and right inputs only. And we save that. It's going to regenerate our C# class. Okay, I think that's done. Yep. And now we want to do strafe is our strafe function. We're just going to copy all of this. For the moment. And we're going to do rigid body dot position vector 3 dot not forward left plus equals vector 3 left times 1. Who knows? Maybe maybe that works. Maybe that doesn't. Let's just see what happens with that. Okay, so now when we play, just A shifts. Okay, it always shifts left. That's a start though, and also the keyboard. Yeah, the arrow keys work. The console controller works. All of them work. Okay, good. But we need to do it based on whether it's left or right. So, how's that going to work? Right, in our strafe, we have a left or right. Composite part negative. It should be positive, yeah? So I think we're always getting, let's just log what our context is here. And for the moment, we're going to not do anything on it. And also we're going to stop ourselves moving here. I mean, that might be more what we want to do as well, rather than our immediate shift on position. And rather than that, it's rigid position plus this. Okay, we'll save that for the moment, and then we're logging out this. Oh, the other thing I wanted to see, we were using something other than the position, but we'll stick with this for the moment. Let's see what it's logging out. Okay, can we clear? Yeah, we can clear the console, right? Oh yeah. Okay, so it shouldn't move forward now. And if we press left, we're getting move, we're getting strafe. And on the strafe formed action, player strafe, keyboard A, keyboard D, keyboard left, formed, key value -1. Okay, and then when we press right, we get a value of 1. So how do we collect that value? That's got a value of -1. That's got a value of 1. And those don't trigger that. This is... Where's the value on that one? Yeah, it looks like those are all linked up properly. So how do I get the value of our input here? We got to that, I think, in this.
We actually have various ways we can do that. We can go directly to the player input actions and call enable. However, if you do it like this, it will actually enable all of the various action maps. So if you have one for player, one for VCOM, one for UI, all of them would be active at once, which is probably not what you want to do. So instead of enabling the entire input actions asset, you can just go to the player. So just go to this action map and just enable just this.
Right, let's have a little look.
Space, there you go, everything works. So I've got the perform action, and it triggered the jump, and it jumped the original purpose. And again, note how here we only have one log. That's because if we're going through this one, we are only subscribing to the perform event. So if we wanted, of course, we don't subscribe to the started or the initial event. But chances are we just want the perform, so this actually much better. Okay, with this working, now let's add some more actions. So on the input action asset, let's add another action. So we can only one button here. Let's name this with movement. And now here is the reason why there's a column for the autosave, which is because of the C# generation. If you have the generation enabled, then it changes one tiny thing. So for example, here change from button to value. Since I changed, then you can see down there that Unity is compiling, so everything's frozen. I gotta wait a bit, and so on. So if you do have C# generation enabled, then it makes sense to disable it, run your changes, and save. And when you save, then let's generate the C# class. Okay, so this is our movement action. Then we're here for the action type. It's not a button, so we're going to use value. And then you can see the for the control type.
Right, so with our strafe, it's value, that's why. And any is fine. Contraction's fine. Save that. Let it recompile. And now, I think if we uncomment that and save that, let's give this a try, see what happens. We press play, and we go left. We always go left. We still always go left. Okay. Ah, because we're always doing the, okay. So what if we do context dot value, read value, brackets? No, how do we read value? It was something like that. But yeah, we don't need this for the moment. That's what's deleting the console. Don't want that, that's fine. We've got strafe and strafe, yeah, that's fine. Yeah, that's fine. Ah, the read value, and then this function, and this is a vector. maybe, can we read it as an int? Context.read value. Okay, so let's make a private int. What are we going to call this? We're going to call this horizontal movement. And this equals our context dot no on no, I just want context. Is it context? It is context. Context dot read value. I don't think we want it to be vector 2 here. We want it to be our horizontal movement. Context is not. Well, context is there. Private messing up. Right, so we don't want vector 2 then. What are the options in here? Vector 2 int? Let's have a look what he does. So what are we trying to do here? We're trying to read in the 1D axis. So Unity read value 1D axis. Input bindings. C#. Let's just do a quick speed test. Yeah, it's not our speed. Why are things taking so long to load? See what else is in here. Read value float. We might have to have a look at this at some point, but that's okay for the moment. So maybe input.getAxis. No, we're looking at our context. Why is this not loading? There we go. Okay. What are these comments? 2 years ago. No, 3 years ago now. Okay, so they're doing a read vector 2. Can we read a 1D input though? Read 1D. This might be it. Oh. Can we do get access? No. Shouldn't be case sensitive. No, it's not. Okay. So context dot. Let's see what we have. Get type, read values button, read values object. I think we want a read value. Now I wish we could see what goes in here. What we do is a vector 2. Let's have a look. What's a vector 2 going to look like if we say this is a vector 2 as well? We're not going to do that just yet. Call it. There we go. Okay. So let's debug log our horizontal movement. And let's stop that for the moment. Okay, if we run this, what values do we get on our horizontal movement? Let's have a look at the console. Nothing? Oh no, here we go. Invalid cannot read values out of x2 from composite axis composite. Okay, because it's not a vector 2, that's the issue. Yeah, start. So what can we do? We can have a look at our context.readValue function. Let's see what values we can read out of that. C# Unity. Oop. Properties, input action, cancelled input control. Let's see, do we have a get value? Input action type, setup, binding syntax. map, not really. Input action, callback contacts, that's what we've got here. So properties on this is our input action that got triggered. Started, start time, value size in bytes, value type. Okay, so can we do context dot value type? Yes, we can. Let's see what the value type is meant to be for this. Hopefully. We run this. Single. Value type single. The read value single. Nope. Let's see what this throws up. What are the possible values of this? Read value of the action, where key value is struct. Read the value of the action. What if we don't put anything in here? What if we just do read value? What does it say? The type arguments cannot be inferred from the usage. Try specifying the type arguments explicitly. Okay. Can we go to definition of read value? Void buffer. Good definition. Go to implementations. No. Okay. So that's not what we're looking for. But if we output the value, if we output the context, and we just ignore this for the moment, let's see what this says again. Can't remember what it said. Okay, and then we run this. Right, and then, so we have action, player strafe, phase performed, value equals -1. Movement strafe, input low level, native input update type. Okay, I don't know what most of this means. Control key interaction, nothing. Phase performed. Time. Callback to contacts. Okay, low level. Right, what T value is a structure. Right, let's go for Unity read value types. Let's just put types. Let's see if there's anything useful here. Yeah, it's a little bit confusing. Okay. Okay, make an input system that's easy for you to manage and comfortable for players to use and configure. Go away. It doesn't need to know what triggered the action. Yeah, that's fine. Right, the old input manager, yeah, you just lift them up and all that kind of stuff. Then instead of using the spacebar, you're just telling it which function. And then, yeah. Fine. So this is what, yeah, what used to be. So where's the new stuff? Drawbacks to the old system, not possible to rebind controls at runtime. No. One problem. Although first glance it seemed like it's much more difficult. It can seem that it's much more difficult. Basic controls can be very straightforward. Install the system, open it. Click install, you get a warning. That's already done. We don't want to do that, so input action. 6 main parts of the input action. Okay. Yeah, we've done all of this. To create a control scheme, that's already in. Gamepad or joystick, that's already in. Bindings, action maps, and to use. Yeah, swap in the action maps, that's fine. Actions, buttons and values. We're getting there, I think. When using the value or pass-through action types, you'll see an additional option to set the control type. This allows you to specify what type of input you're expecting to get from the input and effects which bindings are available. In many cases, you can leave it set to any. However, this value can be useful when rebinding controls. Once you've added an action and set the action type, it's actually again, this is all okay. Here we go. Right, 1D axis. Count start at 0. Progression along the axis. Simply put the middle will always be the middle. Okay. Yeah. Okay. Digital normalize. mode is, yeah. No. Let's avoid triggering both actions when by composite. Gotta be here somewhere. Mouse read value. That's not what we want. The messages. We want to invoke C# events, which scrolls too far. Why did that scroll all the way to the bottom? Here we go. I wonder, have I just been overcomplicating all of this? We just see context.value. Not contain a definition for value. But it does have a value property, right? Value equals -1. Dot get value. Is there something like that? It still wants me to specify the type here. Oh, no. Maybe we call it a float. And re-invoke it. Ooh, okay. Maybe. Not complaining. I don't think it is a float, but let's have a look. So now, if we press left, right? Yeah. That's looking better. Ah, because it is a float because of the joystick. Right, okay. Okay, right. So then, if we say this, so we bring this one back in, and we times the vector left by this. We need another close bracket there. Right. Please, please, do we get left and right control here? It's inverted, but we have a left and right. Okay, that's way better. Right. Now. So if we do vector right instead, because right is positive and left is negative. So that should be okay. So is this all hooked up now? Let's, oh, no, run it once. So we'll do WSD, so A, D, that's correct. Left and right on the arrow keys, that's correct. Left and right on D-pad is correct. And oh, full control over joystick. It's a bit sensitive on joystick, but because I think the joystick input is doing a lot more input. Oh, we lost ourselves. Okay, right. Let's go back to here. Can we, in our inputs, for the strafe 1D joystick we want, gamepad, this one. I wonder if we can just do like minus 0.1 and 0.1 here, and that normalize it. Let's see what that does. Can we dock this somewhere? It doesn't dock into Unity, no. Okay. Right, so when we run here, now, oh, what's the stat? Oh, okay, it locks when I get to. It's only if I continually have different values. If I just hold it on 1, then it will lock on that max value and it's not updating anymore. Okay, so that's not quite what we wanted. Was that the same before? If I change that back to -1 and 1 and save it. I know it's going to reset when I stop playing, but oh, it needs to anyway. Okay. Oh, it didn't reset. Okay, let's do that. I need a reset button as well. Yeah, so if I just do it straight to the left, and we get that 1 hit. Okay, not too bad though. To start. Okay, so why? Wait, is jump still working? Or did we uncouple it somewhere? Oh no, jump still works. Okay. So if we do fall off the edge, we can jump back up. Where are we? There we go. Cool. Right, I think what I want to do is add in a reset command. So here we'll do all control schemes, yep, and add new action. Restart. And what we want to do is we want to bind that to add binding. So these are all going to be button inputs. Yeah, that's fine. So on our keyboard, we're going to do escape. No, escape just escapes anyway. Let's see if we can search for escape keyboard. There we go. Keyboard and mouse. And then on our gamepad, we want it to be our start button, which I think is this one. Yep. Save. And then in here, we want a new one here. And this is going to be private void restart. And then this is going to be dot position equals now how do I do a vector 3? How do I do 0? Let's leave that open just for in case we need to go back to that. So vector 3 position okay, and our start position here where our player is 0, 1, 0. So vector 3 bracket 0, 1, 0. Can't be used like that. Dot set. Nope. Oh, we got to the end of that playlist. Let's have a look for a new playlist. Maybe ambient. Let's see what this is like. I haven't listened to this one yet. So our vector 3 up might be good. Dot up. Because we want a 0, 1, 0 setup. Now, obviously, in a proper game, we'll want this to be like a starting location or something like that. But hopefully, now if we go off the edge and then press escape, nope, press start. Oh, we haven't mapped restart yet. Let's do this. Dot restart here, and that equals restart, and save that. Okay, now we can play. And we'll push ourselves off the edge, and then we press start, and we come back to the middle. Yay! Right, we've got a quick restart option, which is going to be good. It's going to be very useful for testing. Okay, and now we can do our delta moves as well. So we add these in, so we're constantly moving forward. We're just going to save this before anything crashes as well. Right, let's go. So we can go left, we can go right, we can jump, and we can restart. Okay. I think that might be a good point for a little break. I'm gonna maybe go and get a coffee or something like that. Just get some fresh air. So, I wonder how long that's gonna be. I'll go back to the back soon message, And let's set up a timer for that. So Unity, what's that going to be? It's going to be 900 seconds. It'll be like 15 minutes like that, I think. Let's see, what does that say? 15 minutes. Do I think 15 minutes is sensible? Let's put it up to a bit higher than that. Let's put 20 minutes and hopefully I'll be back in time for that. Cool. Hopefully back soon. Just want to take a break from the screen. But we will be back later. Bye.
Thank you.
Almost made it back in time. I think I just missed the deadline there. Just 2 seconds while I set myself back up again. Right. I think we're back. Okay, so where we'd got up to, we just added in some movement controls here, so we can move left and right, we can jump, and we can restart. And that works on both my Xbox controller and on my keyboard. The only thing is, if we use the joystick, it's a bit more not quite as easy to control, so we might have to look at resetting that at some point. But not too bad so far. Let's do that. And I mean, we can probably go back to our endless runner now and have a look at some ideas of what's up next.
Reading the horizontal input will give us a value of -1, whereas the right and D keys are positive, meaning they'll give us a value of +1 when we read them. With this in mind, we can now close the project settings and go back to the script. In the fixed
So these are all the old
I'm going to create
movement
a 3
options.
and call this horizontal move. I'll set it equal to transform dot right multiplied by horizontal input multiplied by speed and multiplied by time dot fixed delta time. Transform dot right is exactly the same as transform dot forward, except that it gives us the direction to the player's right. We can see that if the player has the D or right arrow pressed, horizontal move will point to the right, but if they have the A or left arrow pressed, they'll point to the left, as horizontal input will equal -1. If neither are pressed, it will equal 0, as horizontal input will be 0. Finally, in RB.move position, I'll also add our horizontal move. Now if we go back to the editor and press play, we can test it out. I'll press the A and D keys and the left and right arrows. It all seems to be working. However, when we play, we might want to move horizontally faster than we move forward to give the player more control. To do this, I'll go back to the script and add a new variable. This will be public float horizontal multiplier.
Now I think we want to do slightly different for ours, because I think I like the idea of having set lanes that you can go into.
This means that the player will move horizontally twice as fast as it moves forward. Now if I go back
So at the moment we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lanes.
Also with the camera, I set its position to 5 on the Y. I forgot to undo this when re-recording, as my original recording paused halfway through for some reason, so I had to redo this. The horizontal movement looked a little bit too fast for me, so I'm going to click on the player, scroll down to the script, and set the horizontal multiplier to something lower, maybe 1.5. If I test this out, that seems a lot nicer for me. Remember, you can use any value that you want. Finally, we want our camera to follow the player. This is really simple, so let's create a new C# script, right-click, create C# script, and call this camera follow.
Okay.
Wait for it to compile, and once that's done, double-click to open it up in Visual Studios. We can delete the 2 using tags up the top again, as we won't be needing them. We'll need 2 variables. The first one will be public transform, and I'll call this our player. The second one will be a vector3, which we'll call offset. In the start method, we'll set the offset equal to the transform dot position, so the
vector3
position of the camera, minus the player dot position,
offset.
or the position of the player.
Okay.
This is just a little bit of math that will help us keep the camera the same distance away from the player at all times.
Offset dot
In
transform
Plotly,
position.
transform dot position is equal to the player dot position and add the offset. Now, if I go back to the editor,
Position.
I'll drag and drop the camera follow script onto our main
Wait
camera.
1 second. Transform dot position minus player dot position. Oh no. player dot position. Okay, and then in our update,
player dot position and add the offset. Now, if I go back to the editor, I'll drag and drop the camera follows
just
position
1 second on that.
is equal to the player dot position.
Transform position equals player position
Offset.
plus offset. Okay. So we want transform dot position equal player dot position plus offset. Cool. And then we save that, and then we go back to Unity. We let that run,
Now, if I go back to the editor,
and
I'll
on
drag
main camera.
the camera follow script onto our main camera,
Yep.
select it, and you'll see a slot for the player.
Yep.
I'll drag and drop the player from the hierarchy into this slot, and before I press play, I'm going to drag the game view over to the right, so that we can see the scene and game at the same time.
Okay. Game view we can have over here. Ah, that's cool. That's very useful. Okay, then if we click play, then yeah, you can see that it's following the player. I think we're a little bit close there. Nice. So, if over time we want to increase the speed of the run, let's have a look at doing something like that. So, in our fixed update here, we want another private. Let's just call this int as a speed up. Oh, speed up interval. And we're gonna actually make that public. And what we're gonna do is we're gonna say our speed up interval to start with is so it's 24 frames a second. Let's say maybe every 5 seconds. So 525s is 96. No, 95. 520. No, 125. And then what we want to do is within our fixed update, we say if speed up interval is greater than 0. Yeah, let's do this. Greater than 0. All we're gonna do is we're gonna take one off of that. Speed up interval minus. Right? Else, if it's not greater than 0, speed up interval equals our 125 and speed. I think I can do times equals, right? Let's say 1.2. You can't do times equals. Okay. Equals speed times 1.2. No? Cannot convert double to float. Is our speed is a float? Can we just do float 1.2? No. Okay. Times speed multiplier. Right, and we're going to have our public float speed multiplier. And let's do initial speed. Speed up interval. Speed up interval. No, actually we don't need that. We just want this. And then we're going to say this speed multiplier. Actually, no, I want it in here, don't I? Equals 1.2. Okay, how do I set this to a float? Default value of float C#. Oh. Float. Oh, I can spell. Oh my god. Float C#. Ah, with an F. Ah, so that's what F stands for. Right. There we go. Okay, right. And our speed up interval we're setting to 125. So we don't need that. Let's save that. So that should be every 5 seconds. Wait, we said it was 24 frames a second, right? So it's 120. Not. So every 5 seconds we should speed up by a factor of 1.2. Now, to check this is working, let's extend our platform a lot longer. Our ground is going to go 1,000. So we can really see where it's going. Let's just have a quick check. Yeah, goes off way into the distance over there. We won't need this, but... oh, wait, no. Going way into the distance back as well. Because our Z starting point is halfway of that, right? Is it halfway? What was it before? When it was 10. And we're setting a starting point of 40. We've got 10 behind and 90 in front. Yeah, so this is the midpoint. So we go up to 1,000. Let's go 100 for now. And we put... No, 40, 10... I think we want this to be 490. Yeah, there we go. So we've got a little start point behind us, but loads of distance in front. And let's do a new material. And we'll call this ground mat. And what do we want to do for our ground mat? We want... no, we want... let's go for a nice red. Something like that. And put that on the ground. And can I add planning offset detail? Advanced shade. Can I edit what this looks like? No. Oh, that's quite cool. You can see it on those different options there. Okay, let's maybe import an asset for this. So we go to our animation. We want to go to assets. Can we see what's in here? Don't think so. So if we import, then it gives us an option of which ones to import, I think. Do we see an example? We do see examples. Okay, we don't want them. We don't want anything to start with, right? And then arcade grey background. Do a brick floor. We don't want to look at characters or effects or enemies for the moment. Environment maybe. Maze? No. Dungeon frame. Barrels. Grass maybe? No, that's just the top. Gothic. Those are quite cool. Road. Roads could be interesting. Mountains and platforms, no. Tiles, ground checker. Platform with tiles. Okay, they're interesting. I suppose we shouldn't be looking at 2D because we want a 3D thing, don't we? Food, vegetation, items, icons, arcade, no. Platforms. Sounds, UI. Weapons, okay. We're not going to do that one. Prototyping pack. Let's have a look at what's in this. No, we don't want to do that. Can we not just import assets? You're not sure what this means, you switch an empty project. Okay, so that's the project file completely, rather than individual assets. Not what we want either. Let's see if there's any floor materials in here. We don't need that. Floor materials, where are we looking? So we don't want the example scene, so let's clear all of that out. We don't want that. Materials. Okay, this looks better. Charcoal. Cobblestone wall. Stone wall. Maybe let's have a look at the wood effect. Wooden boards, that could be good. We don't care about prefabs. Some textures. Canvas, charcoal, clay, cobblestone, dirt, fabric, granite, grass, some walls, some timber. Could do some timber. I want this to be like a hallway that we're going to be walking down in the actual game that I'm going to go for. So one of these woods is probably going to be correct. Let's check that and the normal. Oh, and this. Looks like there's 3 different types. Let's import those. Let's have a look. Right, we can close that. Now we have our materials and our textures. What happens if we apply our textures to the ground? And instead the ground So I think we want this as our material. We go here, we go here, we drag that into here. No, let's get rid of this. That should be that. No. Select wood. Okay. Can we add our other bits? Don't know if that's how this works. No, that's not how it works. Mesh render, probe, additional settings, collider. Okay, we have this. Shader standard. That's closing that down. So the tiling in the Z direction is wrong. What is that? It's 10. 100? A little bit more than that. What if this is like 5? 10? No. I think 1 is right there. Yeah, because that's tiling across, isn't it? So 1 is correct. And maybe 500? No, 100 looked better there. 200. 100 is a bit too big by the looks of it. So maybe 150. That looks alright. Okay, let's go with that for the moment. I mean, the other options we had were these ones, which doesn't look like it's set correctly, right? What if we put that on instead? No, so let's undo that. I'm going to stick with that. That's okay. So now what we should see is every 5 seconds our player speeds up. Nice. Okay. This looks like we got the beginnings of an infinite runner here. And we get to the end and then we reset. Yeah, it's super fast. Cool. Right, we need I think we need a top speed cap as well. Or it needs to I don't know, maybe that's alright. Right, should we go back to the tutorial that we were following?
I'm also going to zoom out on the scene view a little bit so we can see more of the ground. Finally, let's hit play. And you can see that the camera follows the player exactly. However, in Endless Runners, usually the camera stays in the middle of the track, even if the player moves to the side. To do this, let's go back to the script, and instead of setting the position of the camera...
That is true, isn't it? So when you move left and right, I don't know, you could do either, I reckon. I suppose it makes it easier if the camera stays in the same spot though. If that, yeah. So let me see if I can guess how it works. So in our camera follow, rather than updating like this, we want our offset, the transform position dot, which rotation are we looking at? We're X and Y is left and right. So X is the only side that we want to update. Dot X plus offset dot X. Can't modify transform dot position because it's not a variable. we just do .x. No. Okay, let's see how we do this.
Replace this with a variable, type of vector3, and I'll call it the target position, target pos for short. On the next line, I'll say target pos dot x is equal to 0. Remember, the x-axis goes left and right, so if we set its value to 0, the camera will always stay in the middle. Finally, we'll say transform dot position is equal to the target position.
Okay, right. So this equals our dot offset. And then target position dot x equals 0. And then this equals this. Right, and then we run it, and we should keep the camera on the right here. It stays in the middle as we go left and right. I think having set lanes to go down makes more sense, just in terms of simplicity. Because if you had this as like a completely free roam, like you do with the joystick here, it's going to be a lot harder to control. Okay. So what we can also do in our reset here is quite simply speed equals initial speed. And speed up interval equals initial speed up interval. Let's do initial speed up interval. And let's make that an input. Here. And we're saying that we want to call this 120 for the time being. And let's do an initial speed multiplier as well. Comes up this. 1.2f, just so we can configure it in the controls rather than having to come back here all the time. These ones are going to go back to this. So if I save, it doesn't get rid of the spaces here. Right, so speed is initial speed. Speed up interval equals initial speed up interval. And speed multiplier equals initial speed multiplier. And actually, what we want to do is we want to do this all in our reset command. Why does it not like you? Initial speed up interval. Oh, because it's an int. Okay, yep. That's gonna like it. That's fine. That's fine. We got rid of our start there, didn't we? Where were we? That's the one we want to keep. Get rid of those. Change this to an int. And cut this from here. Paste it in here. And then we call restart at the very start as well. So on awake, we do restart. Can we not just call it? Can we, is it just called restart maybe? How do we trigger a function? Call function C#. What do I? Should just be like that, right? This dot restart? Is it because it's private? Maybe it's without the... No? How are we going to do this then? Class print void, print name. How do you call a function in C#? What if you're not using main? We're looking here. What are we in here? Player movement, maybe? It's the player movement dot restart. The argument given that corresponds to... Ah, because I don't have a context here. Right. That's the only issue. So, what context do we want? We want our player input action. Player input. Restart. Dot context. What do we need the context for? I don't think we need the context, do we? What if we take this out? Because the restart doesn't care, right? We don't want any input here. Oh, it cares about the button input to trigger it. Okay, let's undo those then. What if we try and do player input actions as our thing here? Nope. Dot player. Dot restart. Dot performed. No, okay. If it doesn't have the context, it doesn't know what it's acting upon, right? Where are we even using context? We're using it there. We're not using it in these. Input action perform.add. So that's subscribing the restart message, restart function to the performed action. Can we trigger an input? Let's see. Unity C# trigger function. Okay, so run. Okay, let's actually search what we're doing. Restart script Unity on pause and game start. Oh, this might be better. Team manager load scene. Okay, scene.name. Let's have a quick look at that, because it's probably another thing I need to load in. Unity Engine.core module. Module? Maybe? Nope. Where's the scene manager script? Using how do you use scene management? You have to add .scene management. Okay. There we go. Right now that's okay. And instead of restart here, we've got our setup, right? Which was speed equals initial speed, initial speed up interval equals, no, speed up interval equals this. The interval equals this. Come on, it's the right buttons. And speed up multiplier, speed multiplier even, equals initial speed multiplier. Okay. So now, does that reload the screen? Scene even? And how long does that take? Might not be the most performant way to do it, but we'll give it a try. So yeah, as we go along, our speed is slowly increasing, hopefully. Which does look like it's doing. We've got our left and rights. Our jump still works. Oh, and we follow the character when we jump, that's quite good. And then, if we press escape, we go back to our sample scene. And we're seeing our velocity increase. Nice. And you can just restart whenever. There's a little bit of loading. See, I'd rather. I think we're doing stuff every time we do this, making it slower and slower. Yeah, we're stacking up assets here. That's not a good way to do it. Right, let's not do that. I think instead we will just, for the moment, do our initial speeds and our initial position, which I think we said was rigid body dot position equals vector 3 dot up, because it just happens to be that's a 0, 1, 0 in our 3D space. Get rid of that training space there. I think if we can manually write in the values, that will be better. Okay, so we're speeding up. And our jump button works. And our left, right. Ooh, being able to dodge in the air as well. We might change that so it's only when you're on the ground. And then when we reset, back to normal. And look, there's no delay, no matter how many times I do this. It's straight into start. Cool, let's save that. No, don't move that to a new screen. This is where we want it. That's what we're seeing still, yeah. Okay, no, not this one. This one.
Go back to the editor, wait for it to load, and then hit play to test. You can see that the player is moving forward, the camera is following the player, and it's also staying in the middle of the track as we move left and right. That's all we'll be covering in this tutorial. In the next one, we'll look at spawning the ground tiles endlessly. If you liked this video, hit the like button. If you didn't, hit dislike and let me know why in the comments. If you don't want to miss a video, remember to subscribe and ring the bell button.
Endless ground spawning. Let's have a look at this.
Hi guys, and welcome to the second video in this series on making a 3D endless runner in Unity. In this video, we'll be creating the ground, spawning it continuously in front of the player, and destroying the tiles behind the player. The way we're going to be doing this is by creating a ground tile, which will be composed of two tiled objects, a plane, which will be what the player runs on, and an empty game object, which will tell the next tile where to spawn. The red dot shows where the ground tile's pivot is, which is the reference point for its position. This means that if we have two tiles, and set the position of one of them to the spawn point of the other, the planes will line up perfectly. With that in mind, let's implement it in our game. As we'll be spawning the ground at runtime, we can go ahead and delete the ground plane that we created in the last video. Instead, I'll right-click and add an empty game object, then press F2 to rename it, and call it our ground tile. I'll right-click on that, and go to 3D Object, Plane. This adds a plane as its child object. I'll set the position on the Z to 5, remember that's forward, then right-click on the ground tile again, and create an empty. I'll press F2 to rename, and call it the next spawn point.
New, empty, next. Next spawn point. So we did this, but I think it was this. No, where was he set to 5? I did hear him say it.
And go to 3D Object Ground at runtime. We can go ahead and delete the ground plane that we created in the last video.
I'm going to leave it in for the moment, the old ground.
And add an empty game object, then press F2 to rename it, and call it our ground tile. I'll right-click on that, and go to 3D Object, Plane. This adds a plane as its child object. I'll set the position on the Z to 5, remember that's forward, then right-click on the ground tile again,
because we went 0 here, reset position, plane, G5, so that's moving it forward. Let's call this ground tile. And at the moment on our plane, let's pull this same texture in. So this one we want to get rid of. We're not using it anywhere. And then one we are using is this guy. So you're going on plane. Can we just unview? Do that. There we go. And then in our tiling, if we do 2 on this, 1.5. Yeah, that looks a bit better.
And create an empty. I'll press F2 to rename and call it the next spawn point. I'll set its position on the Z to 10. If I select the ground tile now, and then the next spawn point, you can see that their positions match what we talked about at the start. If their locations aren't the same on your screen, click on the tool handle position toggle up the top, changing it from center to pivot, and that should solve the problem. With the ground tile complete, I'll right click on the assets folder and create a new folder, and I'll call this prefabs. I'll just drag and drop this ground tile into that folder.
Okay, so we've gone here, create folder, prefabs, and then in here we're going to drag our ground tile,
which creates a prefab of the ground tile. A prefab is just a way of storing a game object with all of its information and components so that it may be reused later. To see what it does, drag and drop it into the scene view, and you'll see an exact copy of our ground tile has been created. Now let's delete all of the tiles in the scene, since we'll be spawning them from a script. Then
That's
click on
cool.
the scripts folder, create a C# script, and I'll call this ground spawner. Give it a moment to compile, then double click to open it up in Visual Studios. We can delete the 2 using tags at the top, as well as the update function.
Ground
as you
spawner.
We're going to need 2 variables, a public game object, ground tile, and a vector 3, next spawn point. Now let's go back to the editor, right click, create an empty game object, and I'll call...
Right, let's just go back a little bit there. Okay, so I assume he's got rid of those again. We don't need our update, and we need a close brace there, and we are going to put in here our public game object, ground tile, and our vector 3 next spawn point. Cool.
Now let's go back to the editor, right click, create an empty game object, and I'll call this ground spawner.
Right. Ground spawner.
Click add component, and we'll add our ground spawner script to it. With that done, click on the prefabs folder, and drag and drop our ground tile prefab into the ground tile slot. Now let's save and go back to Visual Studios. In here, we need to create a new function, so make some space, then type void spawn tile, open and close parentheses, and then a pair of curly braces. This declares a function called spawn.
Right, let's just double check. What did you put in? You put the ground tile from the prefabs in here. Yep. Oh, and let's make sure this is starting at 0, 0 as we want it to.
Now let's save and go back to Visual Studios. In here, we need to create a new function, so make some space, then type void spawn tile, open and close parentheses, and then a pair of curly braces. This declares a function called spawn tile, which returns void for nothing. If we replace void with something like int, we would be telling the script to expect the function to return an integer. As we don't need any output, we'll leave it as void. Inside it, we'll say instantiate, open some brackets, and then put in our variable ground tile, then next spawn point, and then quaternion dot identity.
Ground tile.
Instantiate is how you spawn an object in Unity. The first
Next
input is the object you want to spawn, the
spawn
second one
point.
is where we want to spawn it, and the third one determines the rotation of it. Quaternion dot identity simply means no rotation. Now we can set the next
Dot
spawn point.
identity.
But to do that, we need to be able to reference the child of the object we just created. In case you forgot, the next spawn point is a child of our ground tile. To get the reference, in front of instantiate, we'll say game object temp is equal to this instantiated item. You might recognize this as the syntax for creating a variable, and that's exactly what we're doing here, creating a variable named temp, short for temporary. With this, we can go to the next line and set the next spawn point by saying next spawn point is equal
Game
to
object.
dot transform dot get child. And
Temp
parentheses
equals
plus an
that.
If we go to the ground tile in the editor,
And
by
then
double clicking on it, you can see that the spawn point is the second child after the plane. As we start counting from 0, we'll say that it has an index of 1, and the player will have an index of 0. We can go back to the script now and put a 1.
So next spawn point. Equals temp.transform. Get child. Oh, get child. Index of 1.
In there. Finally, we have to say .transform to get the transform component, and then .position to get its position. That's the whole function complete, but currently we aren't actually calling it from anywhere. To do that, let's go to the start function, and then just call the function, so spawn tile, parentheses, and a semicolon.
Transform temp.transform.getChild, not transform getChild. There we go. And then start, we're doing spawn tile. Oop.
But we want to make sure that it works spawning multiple tiles, so let's copy that line by pressing Ctrl-C without anything selected, and then paste it 4 times with Ctrl-V. If we go back to the editor and run the game, you'll see that 5 tiles have spawned, and they're all in the right position. Great. The problem that we have is that the first tile spawns at the same place as the player, so to fix this, I'll simply select both the camera and the player, and then drag them forward, approximately 5 units. Going back to the start function, there isn't much need to wait to call something multiple times, and that's using what we call a loop. To do
Right, so we want to do this, we want to test this. We save this, go back to here. And we run this and see our tiles spawn in, hopefully. But yeah, we're starting right at the back. Now, can I offset it first? Spawn tile, temp, essentially ground tile, next spawn point. So I think here, if we do a vector 3, dot forwards, maybe. So this should spawn it a meter in front, I think. So let's see this. We should see the yeah, so it's that 1 meter in front there. So what we're going to do is times by -5. Who knows? So hopefully that shifted back 5, which is what we were doing before for the first tile. Yeah, perfect. Cool. And then
just type 4, and then hit tab twice to insert the full snippet. If that isn't an option for you, just copy what is on my screen. The only thing you have to worry about here is that I is less than length. Replace length with however many times you want to call this function. For me, I'm going to say 15, but you can use whatever number you want. Inside the curly braces, we can call our function, so spawn tile, and we can delete all of the ones outside of this for loop. All this does is call our function the number of times that we specify, but it's much cleaner and easier to read this way. Now we have tiles that spawn at the start of the game, but we need to keep spawning tiles as the player moves forward. The way we're going to do that is by having a trigger on our ground tiles, which will call a function both when the player overlaps it and then when the player leaves it.
okay, so instead of length, we're going to call this, yeah, 15 times, that's fine.
When the player leaves the collider, we'll spawn the next tile. To do this, let's go to the ground tile prefab, select the ground tile parent, and go to add component, and box collider. Check the is trigger box, then set its size to 10 on all dimensions so that the player can't possibly miss it, and set its position on Z to 5 to center it.
We go to our ground tile prefab. We're adding a box collider. And we're setting the size to 10 on all scales. And we're setting Z offset to 5. Yep.
You can see that it covers the entire tile. Now let's create a new script. So go to the script folder, right click, create, C# script, and call this ground tile. Wait for it to compile, and then double click to open it up in Visual Studios. You can delete the 2 using tags up the top. We're going to need one variable, which will be type of ground spawner, and I'll call this ground spawner with a lowercase 3. The type of this variable is the script.
Okay, let's let that load first before we get too far ahead.
be able to access functions and variables from that script. We need to set the reference in the start function. So I'll say ground spawner is equal to game object.
Ground spawner.
Object of type.
Ground spawner.
Ground spawner.
And then
parentheses and a semicolon.
In start.
The first object matching the type ground spawner, and we know that we only have one in the scene.
Right. And then our start is ground spawner equals game object. Game object dot find object of type. And the type is the ground spawner. Yep. Find object of type. Dot find object of type. Oh, and then it's a function, so we have to call it. There we go.
So it's safe to do this. Next, create a function called onTriggerExit. This will have an input type of glider called other. This is the default function called when anything exits a trigger. Normally we would have to check that the item that exited was the player, but in this case we know that nothing else is moving, so it must be the player. In here, we want to call the spawn tile function, but if I try to say ground spawner dot spawn tile, you can see that it's not an option. Remember,
can't just see.
Outside of its own script.
I'm wondering if there's a default way to do a function. What would we just call onTriggerExit? Private void onTriggerExit collider other? Yeah, perfect.
Has to have a public modifier on it. So let's go back to the ground spawner script, and in front of the void, we'll put public. So it now says public void spawn tile. Now we can go back to the ground tile script and say ground spawner dot spawn tile. Finally, under that, we'll say destroy. Open print.
Wait, I think we've already got that, right? Go back.
In here, we want to call the spawn tile function, but if I try to say ground spawner dot spawn tile, you can see that it's not an option. Remember, to access something outside of its own script, it has to.
Oh, this needs public, yeah. Say that. Public spawner dot spawn file.
To have a public modifier on it. So let's go back to the ground spawner script, and in front of the void, we'll put public. So it now says public void spawn tile. Now we can go back to the ground tile script and say ground spawner dot spawn.
Hey Runa, how's it going?
Under that, we'll say destroy, open parentheses, game object with a lowercase g, comma, and 2. This is to destroy the game object 2 seconds after the player leaves the trigger.
Okay. Let's push this down here. And let's go. To there. Okay, so destroy object.
We finished with the scripts now, so save and go back.
So destroy game object 2. Now I think it needed to be.
To the editor. Select the.
Oh, just missed that one.
Open parentheses, game object with a lowercase g, comma, and 2. This is to destroy the game object 2 seconds after the player leaves the trigger. We finished with the scripts now, so
Okay, then we save that. Go here.
save and go back to the editor. Select the ground tile and apply the script that we just made to it. If I now exit from the prefab view by hitting the back arrow in the hierarchy, I'll zoom out in the scene view so that we can see more of what's happening, then hit play. You can see that ground tiles are spawning themselves in front of the player and destroying themselves behind it. The final thing I want to do in this
Okay, what did we assign it to?
Now we can go to destroy the game hierarchy. I'll zoom out in the scene view so that we finished with the scripts now, so save and go back to the editor. Select the ground tile and apply the script that we just made to it.
Okay, ground tile, which is the ground tile script here. We apply that to that. And then when we check here, we should see it here. That's fine, yep.
If I now exit from the prefab view by hitting the back arrow in the hierarchy,
Back here, and then we zoom out here and we press play. Oh, why have we jumped up? This isn't working because we jumped up, haven't we? So our player height is 1, our position is 1. Let's have a quick look at where we are. Why are we at y equals 6 instead? So player movement, initial speed, that. Zero, 1, 0. What we wanted. Can't be used like a vector. Vector 3. Set. Position. New vector 3. 0, 1, 0. Okay. No, because we'll be creating a new one each time we do this. So, at awake, here, we want spawn point. Let's call that spawn point. Equals. And this is going to be a private. Can I do it in here? No, let's put this up here. Because I need to tell it it's a vector 3. Spawn point. Spawn point equals new vector 3 here. And then this equals spawn point. And then we've only got one. We're not recreating it each time we call restart. I think. Let's see what happens with that. No, we're still jumping up. Why are we jumping up here? Let's see, are there any comments? Fix the problem by checking is trigger on my box collider for the ground prefab. Okay, so the ground prefab here, box collider is trigger. Don't know what that's for. But I think it might be that this collider is pushing the player object up. There we go. And yeah, we're seeing new tiles spawn in front. Let's rotate the angle so we can keep track of it a little better. And as we're speeding up, oh my god, it's going so fast. But when we restart, we need to reset the ground collider as well. Where are we? We're going to be way back here somewhere. Can't even see where we are. Can we see ourselves? Oh, have we fallen down as well? that might be what's happened. Yeah, we're falling. Okay. So when we restart, we haven't got a ground to start on. Okay. Let's have a little think about that. I'm just going to do a quick break. We've got to select a new playlist again. What do we feel like listening to this time? What is Chill Step? Let's give that a go. And we'll be right back. Okay, where do we go up to? Swap back over. Right, so we are now spawning the task correctly, but we need to reset the ground spawner. If we call reset. So we want the next spawn point here to be a public. And really, what we want to do is we want to say player movement. I mean, I know I'm muddying the waters a little bit here, but this is going to be our ground spawner. Ground spawner. And here. Maybe that. Let's just see if that works for the moment. So we've got to wait until we move forward a couple of frames, and then if we restart, no. Okay, let's ignore the restart thing for the moment. So I have a feeling that moving the ground towards us rather than moving the player along the ground might be the better option. Because then our player, well, we stay in the same coordinates the whole way through the game. Okay. Let's see what's next.
I'll zoom out in the scene view so that we can see more of what's happening, then hit play. You can see that ground tiles are spawning themselves in front of the player and destroying themselves behind it. The final thing that I want to do in this video is add a material to the ground so that it looks a bit nicer. To do this, I literally went to Google Images and searched for brick ground texture. I found this texture, which I'll link to in the description if you want to use it. If not, you can use anything you want. I'll drag and drop it into the assets folder. Then right click, create, material. I'll call this ground _ map, short for material. I'll click on the circular icon next to albedo and select the ground texture that I just imported.
So the problem with this is as we're speeding up, we're getting more and more textures, which we don't want. We don't want to go so far, which is to do with the ground trial destroy. This 2 value, this needs to be based on our current speed. So we made this public, and if we find our player movement speed, player movement we do the same thing here. So player movement equals game object of player movement. Maybe. So as the speed gets faster, we want the time to get slower. To the delay to be slower. So we could just do this as what speed do we start at? We start at speed of 5. So we could just do 10 over player movement. Wait, trigger on exit to 10 over Player movement dot speed. So as we get faster, the tiles get destroyed quicker. We'll see what that does. We're not too fussed about it being exact here, but get a better idea. The music's really fitting for this. Oh. That looks perfect. Okay, we're starting to get a few extra tiles here. But we are going ridiculously fast now. Let's see, where's the player? The player is moving at 400 meters per second. 500 meters per second. See, now we've gone too fast to the tile generation. Okay, so we need a max speed. So all of this needs to be wrapped in an if, not max speed. In here. And then what we're going to say is speed times speed multiplier if speed is greater than let's say 400, then max speed equals true. And we start off with our private bool max speed. And max speed is false. So we might want to change how we ramp up to that max speed, but hopefully that should restrict our max speed to the first value that is over 400. So if we watch our speed here, we're starting at 6 meters per second. We started at 5 and then jumped to 6. So after 5 seconds, we should go up to another value. Why is it not changing? Oh, it is changing. It's just because we locked it when we were. So 25 meters per second, 30 meters per second, 37, 44, 53. So I think we'll change our speed up interval to be a lot bigger. But the ground tiles are keeping up at this rate. And now we should be at max speed. So this 476 shouldn't change, and I think the ground spawner will keep up with this. It looks like we're going backwards because we're at the wrong speed there. So if we changed our speed here to like 400, maybe 450. Yeah, it looks like we're going forward still. So let's do here speed equals 450. We'll set it to true. And I think we can do the ground spawner here in our reset. And we'll look for a ground spawner object. Let's go here. Don't need all these spaces. Ground spawner, public void, public vector next spawn point. I think this should work. And then this is the ground spawn dot next spawn point. I think that should work, but we'll see. What we might end up with though is, where's our player? Zoom out loads. So now if we restart, getting a little bit more confused on it because we've got more tiles because we haven't reached it. Okay. Public void start, and then we can call this function here ground spawner dot start. So that will then call these first 15 tiles. And can we call a destroy on all ground tiles? I think we can. I think because this is public class. Let's do avoid destroy. I should call this public void destroy. And then destroy game object. Do that. And then in our restart, I think we want to move this restart to its own script, but that's okay for the moment. Let's get rid of that. We're not using that. So we are saying ground tile of type ground tile. And ground tile equals game object dot find objects of type ground tile. I will invoke it now, because this is going to be an array of objects. Can I do ground tiles like this? Yeah, it looks like that works. And before we reset it, we'll say ground tiles dot destroy. How do I iterate over an array? 4. Let's try 4 loop. No, 4. We have a 4 for each. Ah, here we go. For each item in ground tiles, we do item.destroy. Ah, there we go. This is what we want. And we'll call item ground tile instead. So we know what we're destroying. Ooh. And if we save that. So what should happen is we destroy all the tiles. Let's move this before the rigid body movement. Right, maybe we might have a reset here. And then ideally we'd move that reset to its own script. So if we run this, that's tiny. Let's have a look this way around. So we can see from the origin, we're going up into the distance. We've got our controls here. We can see our speed is increasing. We can still jump left and right. Probably want a slightly quicker return to the ground. Increase our gravity so it's not as floaty. But if we press escape, oh, we've still got those tiles at the front there. Which is not what we want, because when we escape again, it's going to slow down more and more because we've got loads and loads of tiles. Let's see if this is actually deleting anything. Log. Tile destroyed. Because I've got the R and the O the wrong way around. Destroyed. Now we're in play mode. Oops. We'll check our console. Okay, so when we do this, none of them are destroyed, right? Because on awake, they're not there. That's why. So this has to be done in our restart here. Right, let's check our console. So moving, our player is here, going left and right. Oh yeah, we've still got our output on the left and right. Need to have a look at that. But yeah, as we go forward, we can see all that's happening. If we fall off the edge, the tile stops spawning, but we restart. And it does everything we wanted to. Yeah. I don't think, because there's no item set, when we're destroying them, it's cleaning up everything. So we clear this. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We've got 16 ground tiles most of the time. And when we restart, we should have a log of 16 destroyed. 1, 2, 3, 4, 5, 6, 7, 8. We do now 9, 10, 11, 12, 13, 14, 15, 16. Perfect. Right, we can clear that. We can pause this. We can go back to our player movement. We can get rid of our logs here. It's already gone. This whole thing can go. This isn't doing anything, so that can go. Now, where are we getting our left, right? That's not being used. Debug log here, this one. Don't need you. Don't need you. Save that. Okay, and then when we play this game, so we should now have, we speed up over time, we have left-right movement, we have a little jump, and we have a fully working restart, and infinite spawning platforms. Right, the next thing I want to do so this is constantly moving our camera. Let's see what's next in the
Back to our ground tile, I can drag and drop the material we just made onto the plane to apply it. I will also put the material into our materials folder to keep it clean. If I hit play now, you will see that the game already looks a ton better, just from one small tweak. That's all we'll be covering in this tutorial. In the next one, we'll look at spawning the obstacles that the player has to avoid. Don't forget to like, subscribe, and ring the bell icon to make sure you don't miss another video. Thanks for watching, and I'll see you in the next one. Hi guys, and welcome to the first part of this series on making a 3D Endless Runner community.
let's move all of this stuff.
For the sake of this tutorial, I will assume that you already have Unity installed, so if you don't, install it first, then come back here once that's done. I'll leave a link to another video on setting Unity up from scratch in the description. With that out of the way, let's get started. Here I have the Unity hub open, which is where you can see all of your project, your current Unity version, and general things like that. I'm going to click on the new button in the top right, which will bring up a window asking us to specify a project name and a location to store the project. I'm going to name this Endless Runner Tutorial, and specify a location to store it. Once that's done, I'll click create. You'll have to wait for a minute or two for it to load. With the project open, let's just get familiar with the main windows that we'll be using in the editor. In the middle, we have the scene view. This is simply where we can see all the items in our scene and where they are positioned. The inspector on the right shows us the properties of anything we have selected. On the left, the hierarchy shows us a list of all the items in our scene. Down the bottom, in the project, it shows us all of the assets that we
Right,
have
let's restart that. Wait, no, we don't want player. Oh, it's the thing is in the wrong order.
Hi guys, and welcome to the...
Okay. So the next bit will be obstacles, then coins, finishing touches, and a jump. So we're going to save those for tomorrow. Going to wrap up the stream here. Hopefully it's been enjoyable. Made a fair amount of progress, considering this is all new, this stream. So today we've gone through player controls. We've looked at those all new again, which I don't know where they are now. Here, in our scripts. So our player inputs, we've managed to drag all these in and configure. We've added in our strafe command, we've added in our jump command, and we've added in a restart. Then we looked at following the tutorial from this channel name, Practical Programming, and I'll put a link in descriptions and stuff like that. So we're following on the 3D Endless Runner tutorial from last August. No, oh god, we're 22 now, aren't we? Yeah, a year and a bit ago. So the tutorial's gone through creating the player, controlling the movement of that player, matching the camera to the player movement, and spawning in our ground. Going to be continuing on with the rest of the tutorial tomorrow. Might get through the remaining videos, and then we'll continue tweaking what we've got, hopefully creating our first game and releasing. So that's the plan over probably the next couple of weeks. We'll see if we can get a prototype out maybe early next week, and see how we do. Yeah, thanks everyone who's lurked or chatted and got involved. I hope you've enjoyed it, and I'll see you next time. Cheers. Bye bye.